Okay, we're now going to look at solving trigonometric equations. The first trigonometric equation we have is a very basic trig equation. Sine x equals the square root of 3 over 2, and we're asked to solve for x between the values of 0 and 2 pi. That's the giveaway that my answer should be in radians. Now, this is actually a value that you should know from your unit circle, but regardless, if you're going to use your calculator, which is going to be helpful for several of your equations that you'll do in this class as well as pre-calculus, is to isolate your variable x. Once we've done that, we can find what the x value is. We must get rid of the sign. To get rid of the sign, we'll take the sine inverse of both sides. When you do that, that'll get the x all by himself. Let me just show all my work here. And if you type that into your calculator, depending upon if you're in radian or degree mode, I'm going to be in degree mode, and then I'll just convert into radians in a second. So if I do sine inverse of the square root of 3 over 2, I'm going to find that I get 60 degrees, which I know in terms of radians is really going to be pi over 3. Now, something very important for you to remember is the fact that on your unit circle, you can actually have this value happen more than once. So we know my first one is at 60 degrees, and that's in the first quadrant. My value from the get-go was positive. If I wanted to find the negative values, it would have told me so. But this one was a positive radical 3 over 2. All students take calc. Now, your calculator isn't smart enough to recognize that there is an additional solution. The additional solution is actually going to be in our second quadrant because that's also the quadrant where sine is also positive. So our second solution is also 60 degrees away from our x-axis. So our other solution is actually 120 degrees. Now you're going to need to convert that obviously into radians. So 120 degrees we know is 2 pi over 3, and we have now solved this complete equation. All right, we're going to step it up and solve a little bit more of a difficult trigonometric equation. Our new equation, which again we're going to solve in radians between 0 and 2 pi, this will actually be pretty typical for all the equations you will solve, is 2 times sine of x minus 1 is equal to 0. Just like you would any equation, you really want to isolate your variable. This time, however, we also have a sign, so we're really going to isolate the entire expression. The first thing I'm going to think of is SADMAP. Whenever I'm solving an equation, I always do reverse PEMDAS. So I ask myself, is there anything to add or subtract away? Well, there is. I'm going to add 1 to both sides. So now I have 2 sine x is equal to positive 1. I'm now going to divide everything by 2. So then I have sine of x is equal to 1/2. Lastly, to get x by itself, I need to take the inverse sine of both sides. And when I type that into my calculator, although this is again a value that I should know, I'm going to find that x is equal to 30 degrees, which I then need to convert into a radian, which I know is pi over 6. Again, because it's a unit circle, I know that I can equal this value multiple times. I'm positive 1/2, so 30 degrees in the first quadrant. All students take calc. Sine is also positive 1/2 in the second quadrant, and 30 degrees away from the x-axis would be 150 degrees. So we have 150 degrees and a 30 degrees. Both need to be in radians. So my other answer is going to be 5 pi over 6. Alright, let's look at another trigonometric equation. It's important to note that all your trig equations aren't going to only involve sine. They can involve any of the other trigonometric functions. The logic is actually going to be the same. I have this equation here, 2 times tangent of x plus 2 times the radical 3 is equal to 0. And I want to isolate my x and also isolate my tangent. So the first thing I'm going to do is subtract 2 radical 3 from both sides, leaving me with 2 times tangent of x is equal to negative 2 square root of 3. I'm now going to divide both sides by 2, leaving me with tangent of x is equal to negative square root of 3. To isolate my variable a little bit further, I'm going to take the tan inverse of both sides because this will get rid of the tangent on the left-hand side of my equation. Again, this is actually a value that you should know from your unit circle, but if we type it into our calculator, tan inverse of negative square root of 3, it actually gets us 120 degrees, which we then convert into radians is 2 pi over 3. It's also still important to recognize that we can equal this value somewhere else on the unit circle. All students take calc. Tangent was equal to a negative radical 3. So we know that we're negative in the second quadrant for tangent and the fourth quadrant for tangent. This is the 120 degrees. He's actually one of my 60-degree buddies. So this is also going to be one of my 60-degree buddies in the fourth quadrant. And if we go down from 360 by 60 degrees, we get to 300 degrees. So my other solution is 300 degrees, which I then convert into radians, and I get 5 pi over 3. These will be both of my solutions for this equation. Okay, let's step it up again one more notch. Because you are now in trigonometry, you have the ability to solve equations that have powers. So my next equation for us to solve is tangent squared of x minus 3 is equal to 0. A lot of times, if you have 3 terms, you can treat it just like a quadratic, where you have to have your methods of solving quadratics using factoring, completing the square quadratic equation. Quadratic formula. But this one doesn't require that. We just need to isolate our variable. So we're going to add 3 to both sides. So we have tangent squared of x is equal to 3. We then need to get rid of our exponent of 2. And so to get rid of a square, we need to take the square root of both sides. And it's important to remember that when you take the square root, you have to have a plus or a minus next to your radical, because the quantity that is being squared could be positive or it could be negative. Lastly, we need to take the tangent inverse of both the positive and negative square root of 3. So that's when you can break it up into your 2 cases if you'd like, when you type it into your calculator. Again, this is a situation where you should recognize these from your unit circle. If you type in positive tan inverse, so tan inverse of positive radical 3, you're going to get 60 degrees. If you type in tan inverse of negative radical 3, you're going to get 120 degrees. It's important to recognize that these are all going to be your 60-degree buddies here. And because of our plus or minus, we're actually going to be dealing with them in all 4 of our quadrants. Okay, we have the positive cases of 60 degrees over here. And then on this side, the third quadrant, where tangent is also positive, we are also going to have 240 degrees. We have 120 degrees in the second quadrant and 300 degrees in the fourth quadrant. These are all of our 60-degree buddies, and these will produce positive or negative radical 3s. Once again, we like our answers in radian mode. So we know 60 degrees, that's going to be pi over 3. 120 degrees, that gets us an answer of 2 pi over 3. We know that 240 degrees will get us an answer of 4 pi over 3. And we know that our 300-degree buddy, he will get us an answer of 5 pi over 3. And these will be all 4 of our solutions.